Okay, we're going to look at this story problem, word problem, real world problem, whatever you want to call it. In 1304, Edward I built Warwolf, one of the largest catapults ever used in battle. It had the capacity to launch a 300-pound boulder over 900 feet. The height of a projectile launched from Warwolf can be modeled by the function h of x equals negative 16x squared plus 96x plus 40, where h of x represents the height in feet of the projectile after x seconds. H for height, x for seconds. Graph the function, interpret the key features of the graph in terms of the quantities. Step 1, find the axis of symmetry and the vertex. We want to substitute the values of a and b to determine the equation of the axis of symmetry. So we need to look at a and b. B is 96 and a is negative 16. And that simplifies to oh my gosh. Cool. Simplifies to 3, it says. The equation of the axis of symmetry is x equals 3. This means the x-coordinate of the vertex is 3. Doing good so far. H of x equals negative 16x squared plus 96x plus 40. We're going to plug 3 in so we can finish finding the vertex. They have done this one for us, so we don't have to do the math on our own. They plugged in 3. 3 squared is 9. 9 times negative 16 is negative 144. 96 times 3 is 280. When you combine all of those, you get 184. So the vertex is at 3, 184. A common error when determining the axis of symmetry of a parabola is to forget the negative sign in the equation, x equals negative b over 2a. Remember that if your parabola opens down, a is negative, and therefore 2a will also be negative. Step 2, fill in a table. You want to substitute each x value in for the x in the equation and solve it. Go ahead and pause the video and do that now. Okay, the answers you should have gotten are 40, 120, 168, 184, 168, and 120. Next step is to graph the functions. So you plug in all the numbers that you got and you connect them with a smooth curve. When modeling real-world quadratic functions in a coordinate plane, it's important to appropriately label the axes using the given information. In this case, the independent variable is the height in feet, h, so that's your y-axis, and the dependent is your seconds, x, on the x-axis. Lastly, you want to interpret your key features, right? You want to interpret what do each of these key features mean in the context of our problem. The intercepts, the x-intercept represents the time when the projectile was on the ground. The negative x-intercept has no real-world meaning. The x-intercept is about 6.4, meaning the projectile landed about 6.4 seconds after it was launched. The relative maximum, the vertex is the relative maximum of the function. It represents the time and height when the projectile reaches its maximum height. So the projectile is at its maximum height of 184 feet 3 seconds after the launch. Increasing and decreasing, the function is increasing for x is less than 3, right? So this orange part, it's increasing, and it's decreasing for x is greater than 3, so the green part, it's decreasing. So the projectile is gaining height or growing up, getting higher up to 3 seconds after the launch, and then it's falling back down. Positive and negative, the function is positive for about negative 0.4, less than x, less than 6.4. The interval where the function is positive represents the flight of the projectile. Right, so it's in the positive realms of the y's during this section. End behavior. The end behavior of the function represents the projectile starting and returning to the ground. So start and stop point. And finally, the domain and range. The projectile is in the air for approximately 6.4 seconds, so the relative domain of the function is all non-negative real numbers less than 6.4. Because time cannot be negative, the relevant range of the function is 0 to 184 because the maximum height reached is 184 feet.